Thank you, everybody, for coming. As Paul said, I'm Jayme. This is Weaponizing Systems Administration. We'll be talking about leveraging IT skills in penetration testing. Excited to be here at B-Sides Dublin virtually. Had a chance to visit Dublin a few years ago and really loved it. So happy to be a part of this. So a little bit about me to start off. I work in offensive security in the financial industry. This talk is not representative of my employer's opinions or stances, but I do work in that industry. Couple of certifications in information security, general systems administration, some other things as well. I have a heavy systems administration background. Prior to working in security, I worked as a systems admin for Fortune 100 companies. I worked for some smaller organizations as well, kind of as the solo IT administrator, network administrator, kind of everything in between. And live near DC, and I am Jayme on Twitter. So a little bit about this talk before we get going. I've had a lot of people ask me how to get started in offensive security, and specifically in pen testing. And my usual answer is do some time as a systems administrator or in IT operations and kind of learn those underlying technologies that you'll be attacking and pen testing later. And the more that I thought about that, the more I realized it really is true. There's a lot of overlap between systems administration and between hacking or penetration testing, and wanted to build out this talk to kind of explore some of those. Wanted to show value in an IT operations background. And just as a disclaimer, this is mostly given from a network pen tester point of view. If you're looking specifically at like web app penetration testing, your mileage may vary, but I think a lot of it still holds true. And this talk was originally given at B-Sides DC a few years ago. It's been updated since then, but just in the interest of full disclosure. So by now, it's probably pretty common knowledge that people make mistakes, even systems admins, though they may not want you to believe that. Most breaches that you hear about are due to weak or incorrect configurations in systems. When we look at the news and we hear about breaches, a lot of things that are really trumped up are 0 days and, talking about APT groups that spent months, years, whatever, trying to develop this one exploit for this one particular system. But oftentimes it's the result of really missed patch cycles or a temporary workaround that ended up being not so temporary. Each year, Rapid7 puts out a report called Under the Hoodie. And this describes their internal engagements for the past year, their penetration tests, and the vulnerabilities that are found. And I'm not going to dive too deep into this, but if we look at all the vulnerabilities that they list here, most of them are misconfigurations or weak configurations. And honestly, probably the other category too, right? It's just not specifically labeled out. But we're seeing things that would probably be caught by a penetration test, really thorough security assessment, or just adhering to best practices and being consistent with those best practices. So what does this all mean? Defenders and attackers are looking for the same thing. You're looking for vulnerabilities caused by misconfigurations. Again, we're not seeing 0 days here. We're seeing things that really would have been caught by these misconfigurations. So I want to talk for a second about the traits of a penetration tester. These are things that I think are really important to somebody who is successful in that role. The first being the ability to break down problems into multiple components. If you think about it from a hacker's perspective, you find an exploit, let's say in a web app that allows you to access a file you shouldn't be able to access. Well, you need to break that fact or that concept down into its components. How are you going to get the payload across to actually read this file? How would you verify that the file is read-only or if you have write access? What context is the vulnerable service running in? If you upload a file, where does that actually land? So there's a lot of individual pieces to this that you have to be able to kind of troubleshoot and work within the constraints of to successfully exploit the vulnerability you found. A penetration tester or hacker needs to understand workflow, being able to identify how attacking one system could affect another system. If you're attacking a database, what does that do to the login flow on your end user's interface, right? And you need to be able to identify why an attack isn't working and troubleshoot that. A lot of times exploit code will be pretty basic and might not work right off the bat. So you might have to figure out, what do I actually have to do? Why isn't it working? What's the remediation? And how do I get this working? Or identify a workaround altogether. And finally, you need to be good at communicating complex technical info to audiences that are either very technical, like the engineers you might be working with, or completely non-technical, like maybe a CISO or another business executive who is not necessarily hands-on keyboard every day, but still needs to understand the concepts and understand what you found and how to fix it. If we look at the traits of a systems administrator, you see that there's a lot of crossover. A systems admin needs to be able to break down problems into its individual components as well. How many times has a sysadmin received a ticket that says email doesn't work and has to determine, okay, is that the client, is that the server, is it DNS, probably DNS, is it a routing issue, is it a hosting issue, right? You have to be able to look at all of these things and really break it down to find the root cause. I think that a systems admin really needs expertise in troubleshooting, and that's really where they shine, is being able to take those problems and break them down and troubleshoot each individually and rule them out. They tend to like solving problems, finding workarounds, finding creative solutions to problems. And that's especially true if, like me, you've worked for an organization in the past that maybe didn't have a big budget for IT. You find out how much of your organization can really be kind of held together with bash scripts and creativity, right? And then they also need to be good at communicating technical information to technical and non-technical audiences. You have to be able to communicate with vendors, with support, with escalation staff, but you also have to be able to tell your boss at the end of the day what happened, why was there downtime, how do we fix that type of thing. So this is a sysadmin job post that I pulled off of Craigslist maybe a year ago or so. And just taking a look at this is a very common type of systems administrator job post that we would see here in the States. And look at how many individual technologies are covered. This person that's being hired as a systems admin needs skills in Linux and Windows, troubleshooting, patch management, configuration, Windows servers, security, third-party assessment tool, or excuse me, third-party tools, virtualization, backup, disaster recovery. There's a lot of different concepts here that honestly could be expertise is in their own right. That's a lot for a person to take on. But if we look at a more recent penetration test from a few years ago that I did, this is the technologies that were encountered on a single /24 network. It's a lot of those same things: Windows, Linux, Mac, we have email, deployment pipelines, virtualization. Looking back here, there's a lot of crossover there too, right? So in the end, when it comes down to it, there's not a lot of difference between these two pictures. The person on the left, maybe going through a disaster recovery scenario, I need access to this database, but I don't have the credentials, versus somebody trying to maliciously access the data underneath. I need access to the database, but I don't have the credentials, right? The difference there is the intent of what they want to do. One of them may be trying to bypass security controls to bring the system back online, whereas the other might be trying to bypass the security controls to steal and exfiltrate data. The processes they use are probably going to be very similar. And this is one of my favorite tweets and quotes of all time, which is, sometimes hacking is just spending more time on something than anyone else might reasonably expect. I 100% believe that. Anyone who has worked in IT in any capacity, be it security or operations, can attest to have spent many hours on something when they knew it was either a lost cause or there was a faster way to do it just because you wanted to fix the problem, right? That's really what hacking is. It's not settling for the answer no when you try to access a system or gain access to data, and continuing to spend time trying to get creative and trying to get around those controls. In security, we hear this a lot, especially in the offensive side, which is think like a bad guy, right? And they tell you that on the blue team side as well. Think like a bad guy, figure out what a bad guy would do in this situation, what a criminal is going to do to try to get access to this. And I think there's a lot of value in that. I do think it's a great mindset and very necessary, but I'd also encourage you to think like you manage the system. What processes are in place and what controls have or have not been implemented? And what would you be most concerned about if you were responsible for securing that system? And then figure that out. I think at some point we've all managed a system where we knew there were skeletons in the closet, and we knew that there was something that kind of kept us up at night. And we thought, well, if anyone ever finds this, I'm done. The system is done. Think about where that might be and look at that to start your attacks as a penetration tester. So I want to talk about a few skill sets that I think are core to IT, but have a lot of crossover in penetration testing. This is by no means all of them, but it gives us a good idea of kind of how everything fits in. So first off, server administration. Knowing how operating systems are configured by default, how they're typically configured, that's invaluable. Knowing what services are typically enabled or what services need to be enabled for something else to work is very helpful when you're trying to attack those services. Installation of software, looking at config files, looking at where they're stored, what's in them. Do we have credentials stored inside the config files? Are they encrypted? Are they encoded with base64? Or are we storing them in the registry? How can we quickly retrieve those? And then leveraging that to break into the system or escalate privileges versus just setting up configurations. How do systems interact with other services? Do users log in directly? Are they logging in through a client? Are they logging in and then accessing a backend server? How are things updated? What network ports need to be open? If you take a look at a server and see that port 8443 is open, do you know right away, oh, that's because software X is running, and can you kind of infer what else might be running on that system? Active Directory and group policy. Active Directory is super important. It runs pretty much everywhere these days. Excuse me. Look at things like Bloodhound. Tools like Bloodhound go through Active Directory and parse out permissions, and they look at all of the stacked security groups and figure out how to get to domain admin fastest, right? But how can that be leveraged in other locations or in other situations? Can we look at a user and figure out if that user has elevated privileges by looking at other groups they're members of? Look at Active Directory procedures in general. How are the user roles actually managed? Is it somebody going in and adding users to every role? Is it a administrator going in and adding groups, security groups to a user? How is all of that enforced? And where are the domain controllers? What's on the domain controllers? How is this integrated with other services? That's an important one, because if you're brute forcing a login page and it's tied to Active Directory, maybe you're actually locking out all of the users on the penetration test that you're doing and not just trying to find the password, right? Not realizing that you're actually locking out users. Network administration. Understanding network protocols is huge, even just the difference between TCP and UDP. Understanding firewall rules and the difference between like getting a reset packet and a finished packet back, right? Wireshark and TCP dump are huge, two tools I use all the time. It's very helpful for finding out what's happening under the hood when you're running an exploit or looking at a particular piece of traffic. Actually knowing what the packets are doing and being able to interpret that is really helpful. But as a systems admin, it's also something that you're doing all the time to figure out what your network is doing in general. Routing and switching. Do you know what protocols can traverse a broadcast domain and why a certain attack might not be working? Right? Do you understand the routing and switching? A systems admin will typically have at least a basic understanding. If you have a network admin background, probably an even better understanding of those types of things. And then multi-home systems. There's a lot of pivoting in modern networks. Not all networks are flat anymore. So if you end up exploiting a web server that has several network cards, are you comfortable being able to pivot into another network, or are you stuck on that network? Software and script deployment. This kind of ties back to GPO in a sense. Scripts and their physical locations are defined by GPO. And do you know that you can actually access those scripts as a domain user by just going into the sysvol folder? Furthermore, there's a group policy object for some legacy systems that pushes out the administrator password to the sysvol folder and encrypts it with a really weak key, 32-bit, I think it is. Knowing where that's stored and that you can go in there and pull that administrator password out of a potentially open SMB share, that's huge to know. Other things like system configuration, cron jobs and scheduled tasks, and third-party options. There's a lot of smaller shops that use things like PDQ deploy and PS exec. Those are also things that attackers will use. PS exec in pen testing is pretty common. So it's good to know how that works and how it all fits together. So I learned scripting and programming in general much later in my career than I would like to admit. I think it's something that is absolutely a must to learn to at least read the code. You don't necessarily have to program or have to be able to write code, but to grow out your career and do things consistently and do things quickly and at scale, writing code is definitely a must. One of the ways I learned was to grab some proof of concept code from ExploitDB and just try to customize it. ExploitDB has a ton of proof of concept code out there that's not super well written. It works in terms of triggering the exploit, but it relies on some manual work. So I would take that code and I would start commenting each line. You know, this is where it's setting a variable. This is where it's sending the payload. This is where it's defining the payload, to kind of see what I understood and what I didn't, and then figure out what I didn't understand. And then customizing it too. Can you make it so that an IP address is in line on the command line rather than having to go in and edit this file every time you exploit a system? You can really pick whatever language you want. Python, Ruby, Python, Go, Python, all popular for penetration testing. I'm a big Python fan, but in all seriousness, they're all very popular for penetration testing and for security in general. Knowing any of them is really going to help up your game. There's also kind of a prideful resistance in learning PowerShell for a lot of systems admins, but it's not really going anywhere. Learning how to learn it, if you don't want to learn it outright, I think it's just as important. Learning these two commands, get command -noun and what you're trying to do, and then get help -name, the command you just found, and examples. That gives you probably 50% of what you need to start writing some basic PowerShell. And here I'm going to say something that's going to sound really sarcastic, but honestly, it's not. Do some time in tech support. I don't think I have ever in my life seen so many creative ways to dodge security controls as when I was working desk-side support with users. In the case on the right here, this was an actual real example from years ago where users realized they couldn't send exe files over email. So they would open up WordPad, create a document, drag the exe in there, save it, send the RTF document to another user over Exchange, and that went through because RTF files weren't being blocked. And the user on the other side would download it, drag the file back to their desktop, and they had bypassed our security controls. It's not something I ever would have thought of, but it's a valid method of exfiltration as well. Right? If you have DLP that's blocking certain files, but you can send an RTF out and that's allow listed, maybe that's a way to go. Malware, there's really not a lot of difference between fighting malware and fighting system restrictions for EDR or antivirus. Those things do not like to be shut down. And they will fight you. They will try to spawn in the background. They'll try to prevent you from closing them out entirely or removing files or removing some sort of persistence that they might have. It gives you a lot of experience fighting malware that you'll see as a penetration tester landing on a box that has protective software installed on it. And even looking at where malware persists and how it kind of hides and stays running after reboot and all that, that might give you some ideas as a pen tester on how do you actually maintain persistence on a system that you've exploited. It also gives you a great understanding of how systems work. Being able to really dig into a problem and dig into the logs and looking at how software interacts with each other, I think is really important. There tends to be kind of a desire to just wipe a system, back it up, format it when there's an issue. And I think if you can avoid that and actually do the troubleshooting and try to get to the root cause, you learn a lot that's really valuable later. So native tooling, relying on hacking tools means you have to get them on a compromised system. You never want to end up exploiting a web server and realizing that you can't do anything because you don't have Metasploit installed. Not a good place to be in. Standardizing your processes on built-in tools really help you build processes that are repeatable, that are probably not on block lists, probably allowed and parts of normal systems administration. So to the left here, we have some Metasploit modules, and to the right, their native equivalent on various operating systems. These are all types of things that a system admin is going to do pretty regularly as they're going through managing systems. It's kind of intuitive to add a user through maybe NetUser or user add in Linux for somebody who's done that hundreds of times, actually adding real users. But that said, tooling does exist for a reason, and you need to understand how it works. You need to have a plan B so you can use that native tooling. But at the end of the day, your client or your organization is paying you to cover as much ground as possible in the length of time you have. So don't let that pride of, well, I don't need to use this tool because I can do it manually, take priority. Use whatever provides the most value in your situation. I think learning Nmap scripts and Metasploit framework are fantastic time savers and saves you a lot of effort. And just one last note on native commands. There's often multiple ways to accomplish a task. Relying on tooling means that you have maybe one module or one thing you can run. But if you look at all of these different commands, these are all different ways to transfer a file off of a server. And these are just the ones I could think of in a couple of minutes of writing a slide. There's probably a lot more. And knowing all of these and knowing different ways to move files off of a system gives you options when one fails. If SCP fails and that's what you're most comfortable with, there's 15 other ways to do the same thing. So I'd like to go through a few real world instances where I've been able to leverage system administrator skill sets in pen tests. So none of these use any sort of exploits. It's just built-in commands, knowledge of how systems operate. So this is unfortunately a real scenario, and I know this because this is a past job that I had. This was my scenario. It was a small business, about 50 employees. The longtime systems administrator was fired, and I knew he was going to be let go. I was interviewing for his replacement position. What I didn't know is that I would be onboarded the same, not only day, but pretty much the same minute that he was being fired in another room. I was walking into the office, he was walking into a conference room. So very awkward first day. Of course, this person wasn't happy. So there were no notes, documents, no network diagrams, didn't give me credentials when he left. He just walked out of the building. So I'm new to my position, brand new company, first day. I'm the network administrator and I have no way to administer my network. So what do you do at that point? Well, you hack it. So I rebooted his laptop, put in a password reset CD, reset his local admin password, started looking through folders and finding some scripts that seem to have hard-coded credentials for a backup exec user. Anyone who's ever dealt with backup exec can probably attest that the backup exec user needs a lot of access. What I've seen in the past is most people will fight backup exec for a while, trying to set permissions, and then ultimately give it domain admin permissions, call it a day. So I figured that was a good place to start. And I saw some credentials that were based on a year. So I started incrementing them, ended up finding one that worked, logged in as backup exec, and found out it was, in fact, a member of the domain admin group. So reset the admin password, created an account for myself, found out what was running on that server that I was on, and started doing some scanning, figuring out what other hosts were on the network, what were they running, what other users were around, what types of, just kind of gaining some situational awareness in general, and then documenting it all. Again, this is day one, and I need to figure out what I actually signed on for. But if you look at all of these phases, that's essentially the same as a penetration test. Right? We have initial access by resetting the admin password. We have privilege escalation by finding a user with a higher level of privilege and then escalating to that. We have persistence by resetting the domain admin password, creating a new account, local enumeration, identifying all the services running, some recon, figuring out what else is on the network, and then reporting by actually documenting everything. And as it turns out, taking over a system is not much different than taking over a system. You're doing the same things. Now, compare this to a typical pen test cycle, life cycle. These are out of order, but they're all there. Right? We're doing the same things. So let's look at another one. This was a goal-based pen test with heavy social engineering. I was asked to phish or vish for initial access and then pivot off the user network, get access to a private code repository on a developer network. This is a very, very large software organization. They're in a bunch of countries, tens of thousands of people, and extremely security aware, right? They undergo anti-social engineering training and anti-phishing training quarterly and have to be certified in it. So was in for a little bit of a tough time. So to set up the scenario, I had to perform a bunch of tasks before the engagement started. Registering domains for C2 and phishing, C2 being command and control, and phishing, spinning up web servers, spinning up my C2 infrastructure, my redirectors, Cobalt Strike, configuring security groups, mail servers. All of these different things are tasks that a systems admin is going to do regularly, right? Maybe not installing Cobalt Strike, but installing software on a server that you've spun up in AWS or GCP or what have you, and configuring it so that everything flows and everything works. When the scenario actually began, ended up phishing users for initial access, got some reverse shells, found a domain user that had pretty decent access, and decided to log into their system, start enumerating, again, just getting that basic situational awareness, and found some web servers that were on that sensitive network, that dev network. So I used RDP and the credentials that I had, logged in as the user after hours, and I started just browsing to these internal websites. Found an out-of-band management console. In this case, they were using Dell, so it was iDRAC. If you use HP, it's ILO, that same type of thing. It has a default password, 10 points if you know the iDRAC default password. It should be Calvin. And then the admin user was logged into the console. So the issue with this is console access is literally console access. If you can log into an out-of-band console and the user is already logged in, it's effectively the same as sitting down at their desk with an unlocked computer with the keyboard in front of you and they're logged in. So now I'm the admin, right? So real quick, cat bash history, and I saw a database server that I didn't know existed yet, hadn't found it, on another host, and they had put the password in line. So that was easy. SSH to that other host, and that worked. Grab Etsy Shadow, cracked it, and noticed that MySQL was running on the server that I had compromised initially. So I tried that same password, and what do you know? There's code signing keys, private and public code repository, credentials, API keys, and lateral movement everywhere with the same username and password. So that's a lot to get out of catting one file, right? Nobody wants to be the organization that has to tell their investors that the elite hacking tool that took them down was BinCat, but sometimes that's the case. So another scenario here, this was kind of fun in its simplicity. There was a web application that connected to Active Directory, did authentication over LDAP. The web app had domain admin credentials saved in the config form, but the user that logged in was able to change the server address that it pointed to without entering a password. So some of you might know where this is going already, but we know that LDAP is clear text. It's not LDAPs. We know that we can control where this goes, where this credential goes, and we know that we can hit the test button to see if it connects to LDAP. And when there's an LDAP query like that, it sends the username and password, in this case in clear text, to the server. So all we need to do is run /bin/nc on a server we control, change the LDAP server address to our own server, and hit test. And sure enough, the domain admin credentials came on over, captured them in clear text, and was used to escalate privileges from there. So this is the last one. It was an Ubuntu web server. There was a vulnerability in the app that let me access the underlying file system with write access, so I could write to files. I could do this as root because the application was running as root, so that's really not good. No interactive command execution because, again, I could just write to files, but the great thing here is it's Linux, so everything is a file. A user is basically 3 lines and 3 files: Etsy shadow, Etsy password, and Etsy group. And if you enter the right information in each of those, you effectively have created a new user on that system. And you control the password because you're generating the hash yourself. So the server was running SSH. I went through and modified these 3 files, SSH into the new server, and now I'm on the server interactively executing commands and got root access. So where were the hacking tools in any of these? We didn't really use anything. We were basically troubleshooting all of these systems, but with a different perspective and intending on a different outcome. If we take the penetration testing lifecycle that I showed you a few slides ago, we can reframe that and just ask questions at each of the steps that maybe a systems admin or a network admin would be asking. And we can go through that process. So let's take a look at that again. Recon is just what's on the network. Enumeration, what's on the server? What's it running? Initial access, how do I log in? And you can answer that as creatively as popping in a password reset CD and rebooting, or brute forcing, or what have you, but a lot of different options there. Exfiltration, you can ask, how do I back this up remotely? How do I get this off of the system with whatever restrictions are in place? Persistence, how do I make sure I can get back into the system later? The last thing you want is to gain access to a system, get disconnected, and not be able to have a way to get back in. And then lateral movement, what else can I access from here? When I was in the first scenario, I had admin on the system that I had logged into, but I had no idea what the other servers in the rack were doing. So can I move to those other servers and start enumerating them? And Privest, how do I log in as root? I'm already logged in, but how do I log in as a user with more permissions? And then finally, you have the reporting phase. How do I explain this to my boss? Or how do I explain this to another systems admin? 2 different audiences, and they're going to have 2 different types of explanations, but that's the same as essentially writing an executive summary in a report and writing the technical details. So we'll switch gears a little bit, talk about making the jump to an offensive security role from a systems admin role. I'm going to give you my experience and things that I've seen that work, so your mileage may vary, but we'll talk about each of these. The thing I would recommend most is take on security projects within your role. Definitely ask, work with security if you have a security team and talk to them about what you can help them with, but also think about what you can do within your own role. If you're a systems or network admin, maybe scanning the network for systems and services and seeing if anything new pops up, or if anything is running older software, older services, remediating that, that's a security issue, right? Asset inventory is maybe the most boring thing you could possibly do in technology, but in security, it's one of the most important. I can't tell you how many pen tests, red team operations, and bug bounties I've seen started off with somebody discovering a system that the IT team had forgotten about and hadn't patched, hadn't hardened, didn't even know was there until the vulnerability report came in. Audit account access. Look at your file shares. See who has access to what. Look and see if you can anonymously log into sensitive shares. That's things that penetration testers are going to do regularly. Looking for hard-coded passwords in scripts and in files. Again, super common. Scripts are usually stored on the network share, so leverage number 2 with number 3. And then test deployed application for default passwords. If you went through your network and found every web interface and just typed in admin admin and admin password, you would probably be surprised what you find. A number of applications that I've gained access to were using default creds. That would make a attacker's life much more difficult if you were the network admin or the systems admin finding that first and fixing that first. You can even kind of make the jump to offense starting in technical support. Look at phishing campaign reports and look at the evidence. Look at what phishing messages make it through your security controls versus what do not make it through your security controls. Having that insight helps tremendously when you're tuning the controls themselves, but also when you're generating phishing campaigns on your own. When you get a system in, look at the user account and see if it's overprivileged. See if it's in maybe a security role or a security group for a previous role. Use your position to deep dive into system tools. I mentioned earlier that if you can avoid just wiping the system and restoring it, you can really gain some insight into how the underlying systems work and how the different tools on board work. And I mentioned that asset inventory was the most boring thing in security. The second most boring is probably building out documents and procedures, but it's also one of the most important. Being able to replicate something consistently, very, very important in security. And having documentation also is important for being able to show that you know how to write. The first pen test job I ever got, the interviewer asked me for a writing sample, and being able to provide a document that I had written, a technical document, is one of the things that helped me get that job. But how do you do this without actually going through the steps and labbing out some of the situations that you would find? There's a ton of premium offerings you can find for lab environments to do penetration testing kind of practice or learning the ropes. Offensive Security Proving Grounds are a great one. Hack the Box, Try Hack Me. I believe Hack the Box has a free version as well, as does Try Hack Me, but there's other free resources. You can download VirtualBox or VMware. Download some Linux ISOs and some trial images of Windows servers. Just set up your own environment. For cloud is huge right now. Any experience working in AWS, Azure, GCP is going to be huge on when you're making the move to offensive security. Looks great on your resume. And all of those services give out a certain amount of free time in the cloud. So I think AWS does like 12 months of free microservice. Azure does $100 for the first year, or something along those lines. So leverage that. Use the free trials and the free credits available to you and spin up some servers. You've also got intentionally vulnerable systems. VulnHub, Hack the Box, Metasploitable. Those all have walkthroughs available. You can look at either online YouTube or on individual Blogger pages. And I have a resource page coming up that lists some of those out. And finally, just unpatched Windows and Linux systems. Throw an old XP box on your network. Don't patch it and see how many different ways you can exploit it. In terms of exploits, read about them, understand how they work, lab them out, install a vulnerable piece of software, and then change some things, change some variables. For MS17010, it's the Eternal Blue exploit. Try disabling SMB1, try disabling it entirely, firewall it off, enable Defender. Look at these different things and determine, how does it look on the attack side? What responses do your payloads and your exploits give you? And how does that change as you go through each of these? That'll help you later kind of infer what's going on the other end when you're doing a zero knowledge penetration test. And then lastly, consider reframing your resume, but be honest, because interviewers will know when you're just pulling their leg. But you can change some things around to be more security focused. So instead of creating system inventory scripts, tell them you built out a procedure for detecting new systems on the network. Tell them what you enumerated and what you did from there, who you reported it to, or how you handled remediation. Instead of just saying you administered Active Directory, say that you created group policies, you managed security groups, you audited account access. Again, all things that are really important in a security role. And finally, if you're at a smaller shop and you're responsible for running, let's say, Qualys, Nessus, what have you, talk about configuring the jobs, talk about reporting the findings and how you manually verified, or if you manually verified, how you handled remediation, how you passed all that off. It's all really important, and it's the type of thing that offensive security professionals do every day. And then finally, just some resources. I will post the slides on Twitter after the talk, so you're welcome to grab the slides and take a look at some of these resources. And that's it. I really appreciate everybody spending your Saturday with me and discussing systems administration. Got a couple of minutes left, so if there's any questions, I'm happy to take them.
Thank you so much, Jayme. Great insight. We've one question here. It's asking, do you think that the demand for blue team staff will outpace that for red team in the industry? We always hear about the technology skills shortage and the likes, but it seems to be a little bit asymmetric. The demand seems to be more for blue team. And if you think that is the case, do you think purple team is the future?
Sure. So I think there's always going to be a need for blue team and for red team. I think of it kind of like as a boxing match, right? You've always got the person that's doing the boxing, but you've also got the trainers, and you've got the people that are standing in the ring, and they're helping them get better. That's kind of what I see the red team and the offensive side doing, is really helping the blue team understand what the attacks look like from a practical aspect in the real world. I think there's definitely a need for both. And I think, honestly, folks that are good at red teaming have done some sort of blue team before, whether that be SOC work or systems administration. Knowing both sides of it gives you a tremendous leg up. I think there's a ton of value in purple teaming, and I think that we'll start seeing that even more than we are now. Doing purple team exercises in addition to doing like the zero knowledge red team tests or doing penetration tests, it really levels up your defenders and helps them understand what they're going to see and what they should be seeing, but in a way where they can ask directly and say, was this you? Is this specific IOC something we should look out for? And it also helps your red team because now they know what types of defenses and detections are available. So hope that answered the question.
Yeah, I don't think there's any more questions. There's no more questions there. So appreciate that. And thank you very much for your time today.
Great. Thank you very much. And hope everyone enjoys the rest of the conference.
Thank you.